Okay, our lesson today just starts with some definitions, some things that you need to know. Some of these you may be familiar with and some may be new to you. So discrete and continuous are things that you probably haven't talked about before. Continuous, so you can read the definition yourself, but a continuous graph or function is going to look something like this, all right? Something that is connected. So it could be curvy, or it could be a straight line, or it could do all sorts of things, but continuous just means it's all connected. Discrete is going to mean that we have separate points. So a discrete graph is just going to have separate pieces of data or information points that may or may not be related, but they're not connected in any way, shape, or form. They're just individual points. All right, domain and range, you should know. So domain are your x values. Sometimes we call those input values. And range are y values, sometimes called output. And then a relation is a set of ordered pairs. Remember, an ordered pair is like x comma y. So a relation would have a few different ordered pairs in it. And a function is a special type of relation in which each input has exactly one output value. And we'll talk a little bit more about how to determine that in a few slides. Okay, so the first skill that we really need to work on this week is being able to interpret graphs. So just to use our vocabulary that we just learned, the graph that you see right here is called continuous because it's all connected. So this is an example of a continuous graph. And it's not going to be perfect. We're only doing 2 examples, so you do need to somehow draw that graph in your notes just so you know what we're referring to each time. So it says the distance a delivery van is from a warehouse varies throughout the day. So when this says distance, it means distance that the van is from the warehouse. So for example, this first point, the distance between the van and the warehouse is 0, which means the van is at the warehouse. The furthest it ever is from the warehouse is 5, right? Because that's when the distance between the van and the warehouse is the greatest. And this is talking about over time, 8 a.m. to 5 p.m. So part A, you can call this example 1 in your notes. We're only going to do 2. Part A says segment 1 shows the delivery van moved away from the warehouse. What does segment 2 show? All right, so segment 2 is still showing that the van is moving away, but you may notice that it's not as steep. So it's moving away, but maybe more slowly. Okay? Based on the time frame, which change in the distance from the warehouse is represented by 6? Okay, so notice in 6, so that we just talked about 2, notice in 6, the van, or the distance is going down. That would mean the van is getting closer. So based on the time frame, to me, that makes it sound like the van is starting to return back to the warehouse. So this is going to be the return trip, or the start of the return trip back to the warehouse. Which line segments shows where the distance did not change? Okay, so if the distance is not changing, the distance is remaining constant. Okay, so these constant intervals are the ones that are flat. All right, so the answer to that, the distance, so in my notes I would write distance did not change for 3, 5, and 7. And if the distance isn't changing, but time is passing, that would indicate, so our explanation for that would indicate that maybe the van was at a stop, like a delivery point, right? Because they're stopped for a length of time. It's not like they just, this is from 8 a.m. to 5 p.m. So that's not stopping at a red light or in traffic. That's stopping potentially for a delivery. So if you look at that, it looks like there are maybe 3 deliveries in this scenario. Okay. All right, so the last little thing that I want you to take a note of, it kind of has to do with this reflection question at the bottom. And I just want to talk about the increasing segments and the decreasing segments. So we talked about these are my constant segments. If you read, all right, 1, 2, and 4 are all increasing. 6, 8, and 9 are all decreasing. All right, because from the left to the right, it's either going up for increasing or going down for decreasing. All right, and this is our only other example today. We just need to make sure that you remember all the different formats. One of these may be new, so we'll call this example 2. And this says I have a relation. So remember, relation's a set of ordered pairs. So this is what a relation looks like. It represents the age of students and the words per minute that they can write. So the first format that you might see information given is in a table. So you need to write down a table. And we're going to go ahead and put our x, y values. Remember that ordered pairs are written x, comma, y. So my first ordered pair here is going to be 5 in the x column, 10 in the y. All right, then we're going to have 6 and 20, 6 and 23, 7 and 35. All right, so there's my table. We could also have information listed in a graph. So you're going to see these in all different ways. So in the graph, again, we plot x, comma, y. So 5, 10 means I'm going to go 5 on the x-axis and 10 for the y-axis, all right, which is going to put me right here. 620 puts me there. 623, all right, we kind of have to estimate that one, but we can squeeze that in. And 735. All right, this is an example of a discrete graph. All right, they're not telling me to connect anything. They're literally just listing 4 separate points. So all I'm allowed to have in my graph is 4 separate points. If this is just kind of a side note to you, if you connect the points, you're secretly including like an infinite number of points where all of those are connected, and we don't want to do that. Oh, goodness. All right, I erased my graph. Let me get it back up there for us. 510, 620, 623, 735. You may hear a baby in the background. All right, and then the last part that we're going to talk about this is called a mapping. And when we list a mapping out, it works the same way. So we're going to list all of our x values in the first category. And even though 6 is listed twice, we're only going to write it one time. So 5, 6, and 7. And then we're going to list all of our y values, 10, 20, 23, 35. All right, what a mapping does is it just gives kind of another visual picture of how some of these things are related. So they use arrows to say which things pair together. So 5 gives you 10, right? Somebody that's 5 would write 10 words per minute. Someone that is 6 writes 20, and then another person that's 6 writes 23. Lastly, 7 writes 35. Okay, so this is what a mapping might look like. And you know that you have the arrows drawn correctly because there should be 4 points. So you should be able to count 4 arrows. 1, 2, 3, 4. All right, the only other directions, it doesn't say this in the directions, but we're going to do it because we need some practice. We just need to make sure we know what we're doing. We need to be able to say domain and range. So for the domain, we said we just list the x values. So my domain here is going to be 5, 6, and 7. Again, because the 6 is the same number, you only have to list it one time. All right, my range are my y values. So my range are 10, 20, 23, and 35. And the very last thing I want to talk about is this a function? And there's 2 ways to talk about that. If it's a function on a graph, we can use something, so I'm looking here in the graph in the middle. I know we got a lot going on right now. In the middle on a graph, well, you can use something called the vertical line test. Vertical line test. And the way that test works is anytime I draw a vertical line, it's only allowed to touch one point on the graph at a time. So like right here, I'm touching 1 point, so that's okay. That means it is a function. All right. If I move my line to 6, though, it's touching 2 points at one time, which is not allowed. All right. So if it were me and I was taking notes, I might write vertical line test. Show yourself that this is the point of, we can say that this is the point of failure, which means this right here is not a function. Another way to check function, remember function is that each input has only one output value. So if I look at the mapping, it's almost even easier to see on the mapping. If you look at the mapping, we want to know, does each input have only one output? And notice that 6, all right, right here, 6 has 2 different outputs, right? One of them is 20 and one of them is 23. So because there are 2 different output values, again, it is not a function. All right, so make sure that you understand most of those definitions, and we'll keep working on this stuff in class on Tuesday.